Well, I think what we're using in the rocket at the moment, I mentioned it earlier, it's an egg timer quantum, it's called. We buy it off this guy called Chris Serving in America. I don't know if you've heard of him, egg timer rocketry.
I have heard of the egg timer. It's very common at EuRoC.
We're trying to use those. You buy them in components, would say. He has the PCB, the components all there. You just have to kind of put it together, and it's definitely handier. Like if I was to go and design that myself, like it would take a month of Sundays, you know, it'd take ages to design all that and test it. So it's quite nice having it.
Well, saying that, Sean, as well, I think going forward we're going to have to 2 seconds there. No, wait, I'll show you something I was messing around with during the summer. It didn't come out. Yeah. I think the egg timer quantum or quasar I think we have is
quantum.
Like that's using an 8266 chip. That's after going on the camera. Yeah, you know, like if you wanted to start doing stuff there, like where you're like, it seems like you like working on the hardware side of things. I'm by no means an electrical engineer, and in fact, this circuit doesn't really work well, which stands a testament to that. But like, you can start off and get a microcontroller like that. That's an 8266, and that's the same chip that's on our flight computer. And I think this is most of the I have a barometer here, and an IMU, and that's what we're buying on an egg timer, and we're spending more money on it. So like, what Sean Burke says there about being hard to put together, he's just whining because he had to do the soldering on that like 2 months ago, and it took him an hour, or not an hour, like 6 hours to do.
It took 6 hours. Yeah.
You can definitely go about building it. So like, even you're talking there about making your own hardware. Maybe there's someday they're like you set up your own company and you're making your own hardware from the ground up specifically for space, you know, space hardened hardware for stuff. But definitely, I think Arduino is a good way to start anyway for us. Some people who aren't as as technically advanced in that kind of space.
Another useful thing is breadboards, of course, for circuits. Many times it's much better to use a breadboard than soldering. But when you're doing power electronics, then you risk melting the breadboard, as I have done many times. It's actually interesting how the traces start glowing red. But
when you're doing your liquid rocket engine, actually, could you actually tell me more about that? Because I'm always interested to hear about people building their own liquid rocket engines. It's something I think I'd like to do myself, and even like HiPR would like to do themselves going forward.
I wouldn't recommend copying my liquid rocket engine. I mean, there are a couple of reasons why it's not really good for a well-made rocket. First, I used just air as an oxidizer, and that changes quite a bit of things during design, mostly for the injectors. Also, if you use air, you have much lower operating temperatures than if you use oxygen or nitrous oxide. Also, it just wasn't well made. I didn't really spend enough time to try to optimize it. However, I would like in future to try to make it better, like using more metal and less tape and cardboard.
But you had tape and cardboard rocket. Did it just burn when you started igniting it, or what happened?
Well, I always say it worked for 5 seconds. Then it started melting.
Expendable, I suppose. What did you say your fuel was? So liquid oxygen, or like air, just as your oxidizer, and what was your fuel?
Yeah, so I decided in the end to use ethanol as the fuel, just 90% rubbing alcohol. It's quite good as a fuel. Probably would have been much easier to use like propane or butane, because ethanol does not want to mix with air. It does not like mixing. If you use propane or butane, it is much simpler.
So that those would be your changes. It'd be like either change to like nitrous oxide and like maybe use ethanol again, would it be? And like, did you make, how much of it was cardboard, and like, did you have any metal in it?
In the first prototypes, I had a 3D printed nozzle, like a PVC tube or sometimes a cardboard tube. But in like the later tests, I used a metal nozzle and a metal tube. But the injector was 3D printed.
I think one of the things I've kind of been looking into a small bit in terms of rocketry, and Jay is another person in our society who's really interested in propulsion. Building a nozzle, like, or building those parts out of metal, like, all the solutions we see to that are like use a lathe to get your nozzle shape. But how did you go about getting your nozzle out of metal? Was it lathed, or was it just cobbled together with parts you found? Or
I asked someone to use a lathe for me.
Oh, cool. Okay, so I was hoping you'd say that you didn't use the lathe and you had some other method of doing it, but
well, there are other methods, of course. You can cast it.
Or are you talking maybe about like an aluminium cast yourself at home?
Yeah, you can do an aluminium cast. Like the Astra Bremen team, they made many casts out of aluminium. It's not that hard, actually.
Actually, that's a good. I hadn't thought of that, actually. Yeah.
Yeah. So what you want to do is probably do like a green sand casting, or maybe lost wax casting, lost foam casting, something like this. Maybe lost wax casting would be the best.
Yeah, because I suppose you could like 3D print your mold, melt your wax in there, and then I suppose you need your mold to be something more heat resistant than 3D printed plastic, I suppose. But
yeah, so lost wax casting, what you do, you make the shape you want out of wax. you can like 3D print a mold, put wax inside, and that's it. And then once you have your wax nozzle, you like put it in plaster concrete with a hole, and then you just put it in the oven once it's dry, so that all the wax melts and goes out. Once you have your molten aluminum ready, you put it in the hole and you make your nozzle. Oh, and to remove it from the plaster, you break it with a hammer.
That's cool. I'll look into that last week. Yeah. Thanks, Edo. I've learned something now after that today.
If you want like more advice about how to melt aluminum, you want a clay graphite crucible for a crucible. You can either get like an electric furnace, or you can just use a blowtorch, like a big blowtorch.
Yeah, that's very cool. Thanks, Edo. I think we'll definitely endorse you on LinkedIn after the interview, 100%. Been very enjoyable the past hour or so, and I've definitely learned something there anyway in the last bit. Food for thought, I suppose.